So this is the section 4.1 video. It's kind of an introduction to factoring, and most of what we're going to talk about in this video you probably have seen in Algebra 1. So first of all, we're going to take a step back. If I said we want to multiply this 2 times the parentheses, then I know we would use the distributive property, and so I would get 6x and then plus 2. For number 2, same thing, I would distribute the 5. So I'm going to get 5x minus 15. And for number 3, I would distribute the 10 to both of these, and I would get 40x plus 50. Okay, so that's Algebra 1. But what if we want to think backwards? What if I know that I'm going to end up with 3x plus 12, and I know that there was a 3 out in front? Then does it make sense that the first term I know would have had to be an x, and then the second term would have had to be a 4, because when I distribute that 3, it's going to take me to the 3x plus 12. So look at number 5. By the way, there's a mistake here on number 5. This should be a minus sign. Let me fix that. So again, if I know that the 7 is out in front, and I'm going to end up with this 7x minus 21, then does it make sense that I know the first term would have to be an x, and the second term would have to be a 3. That way, when you distribute the 7, you'll end up with the 7x minus 21. On number 6, this time I'm telling you, hey, I know I'm going to end up with 10x plus 55. What if I know that the parentheses is 2x plus 11? Then does it make sense that it would have to be a 5 that would go out in front, so that when I distribute, I'm going to end up with the 10x plus 55. What about on number 7? What would have to go out in front to be multiplied by 3x to get the 9x? Well, wouldn't it have to be a 3? And hopefully you can tell that makes sense. If you were to distribute, you'd go back to the 9x plus 15. All right, on number 8, what if I have to figure out the whole thing myself? And so it might be that some of you think to yourself, well, if there were a 2 out in front, and this were a 2x, and the second term were a 10, that would definitely give me the 4x minus 20. But then others might say, well, what about, would it work if I had instead a 4 out in front, and then that means the parenthesis would be an x minus 5. And both of these would work, but we would say that the 4 is the greatest common factor, and so we always want to try and get the most out in front as possible. So looking at number 9, with that in mind, the most we could take out, instead of just taking out, let's say, a 2 or a 3, is we could take out a 6. And if I do that, I would have 2x minus 3. Okay, so consider number 8 above. The number on the outside of the parentheses, and I said number 8, it could be any of them above. The number on the outside of the parentheses is called the common factor. And actually, I could say, if you're referring to number 8, if I take a 4 out in front, like we did on number 8, we would say that that would be the greatest common factor. Probably back in Algebra 1, you would have referred to that as GCF, greatest common factor. So, if I look at this next section, if I want to factor, and remember we always want to take out the greatest common factor, then for number 1, instead of just taking out a 2 or a 4 or an 8, I could take out a 16, and that'd leave me with x minus 2. Or on number 2, I could take out a 2, that's all I can take out. I'd have 4x plus 5y. On number 3, I think the most I could take out would be a 5. That'd leave me with 2x squared plus 3x minus 4. And then on number 4, we could take out a 10 as a common factor, and that would leave us with 3x squared minus 5x minus 1. Don't forget, if the whole thing comes out, you still have a 1 left at the end. Okay, so what if this time I do my distributive property, but notice what's on the outside has variables in it. You know, maybe it's numbers and variables. So if I were to distribute, I would have 3x squared plus 8x, because remember the idea, when you multiply x times x, you add your exponents. On number 2, if I distribute, I would have 15x squared, because not only do you have to multiply the 5, but you also have to multiply the x, and then plus 5x. And number 3, when I distribute the x squared, you add your exponents, so x to the third minus 5x squared. On number 4, you would have, if I distribute this all the way across, you would have 3x to the fourth plus 12x to the third minus 18x squared. And then we'll look at number 5. What if you have more than one variable? That's fine. You still just distribute to everything inside. I'm going to have 6x squared y plus 10xy. And I don't think we need to do number 6. That's just a duplicate. So based on the previous multiplication problems, you can see that the common factor, meaning the number out in front, it can be numbers or variables or both. Okay, so let's do some practice. Look on page 128. Let's practice. It says we're going to factor using greatest common factor. Let's not worry about number 1. So if you look at number 2, you've got x squared minus 7x. I think we can factor out an x, and then that means the parenthesis is going to be x minus 7. Okay, now look at number 3. Notice they both have an x, but they also both have a 2. So I could factor out a 2x, and then I would have x minus 4 left in the parenthesis. Let's not worry about number 4. Look down at number 5. So whenever you have multiple numbers and variables, I think it's easier to look at one part at a time. So let's start by looking at the 9, the 12, and the 6. So if I'm looking at those 3 numbers, there's a common factor of 3. All right, then let's look at the x's. I have an x squared, an x, and then an x. So the most x that I can take out will just be a single x. And then if I look at the y's, I've got a y to the first, y squared. So the most y I can take out is just going to be a single y. So then what I have left in parentheses is going to be 3x, so the y is completely out, plus 4, but I've taken out both the x and the y, plus, so when I factor 3 out of the 6, I'm going to have 2. So that x is coming out, but then I'm going to have a y left. Okay, so that's kind of common factor. One thing I want to mention on number 6, I think most everybody could easily tell that the common factor is 3. And so you're going to have x plus 2y. But this last part I always see mistakes on. You might say, well, if you factor out of the 3, it's gone. But you still have to put plus 1, because when you check it, right, when you distribute the 3, you need that plus 1 in order to get that plus 3 at the end. Okay, so the next kind of factoring we're going to look at has to do with these shortcuts related to FOIL. So if you were to look at this, if I said, hey, multiply x plus 4 times x minus 4, you'd probably say, okay, I'll do FOIL, right? So I would have x times x, so first is x squared, the outer is going to be minus 4x, the inner is going to be positive 4x, and then the last is going to be minus 16. And I think at that point you could say, oh, look, minus 4x and positive 4x cancel. So all I have is x squared minus 16. So what I want you to recognize is the reason the middle terms canceled is because when I was multiplying, these parentheses were exactly the same, except for one was a plus and one was a minus. Whenever that happens, that's when those middle terms are going to cancel, and it's just going to be the first and the last. So if you recognize that, you don't have to go through all the FOIL. Like on number 2, I see the pattern, exact same thing except a plus and a minus. So it's just going to be the first, which is x squared, and the last, which is minus 100. Or on number 3, exact same pattern. So it's going to be the first for x squared, and the last, minus 25. And on problems like 4, 5, and 6, it doesn't matter that the number is first and the variable is second. Don't rearrange it. So same pattern. First is 9. The last is minus x squared. Remember, we can do this because we notice the pattern of the exact same thing, just 1 plus and 1 minus. So this would be 81 minus x squared. And then number 6 would be 49 minus 4x squared. All right. So now think backwards. If you recognize that what you're trying to factor is just two perfect squares. What do I mean by perfect squares? Well, 25 is a perfect square because it's 5 squared. 36 is a perfect square because it's 6 squared. 49 is a perfect square because it's 7 squared, okay? So I can see this is going to turn into the pattern above. This would just become an x plus 5 and an x minus 5. So this only works if those are both perfect squares. So this is going to turn into an x plus 6 and an x minus 6, right? And a lot of people forget that 1 is a perfect squared because it's just 1 times 1. So this is going to be x plus 1 and x minus 1. This would turn into 3x plus 2 and 3x minus 2. Again, remember, I can do this shortcut because both of these terms are perfect squares. On this one, I'm going to get 5x plus 7 and 5x minus 7. And then this one is going to turn into 10 plus 9x and 10 minus 9x. So whenever you notice this kind of a pattern, this shortcut is called difference of squares. Difference of squares, because difference means subtraction. So whenever you are subtracting perfect squares. Right? And remember, perfect squares are like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, or 12 squared. So those are all the perfect squares you need to be familiar with. So when those numbers are involved, you can do this shortcut. Okay. So if you look on page 129, we're going to come back to 1 through 6 in just a minute. First, look at this middle of the page. Notice it says, does the shortcut, meaning the shortcut we just talked about, does the shortcut work if it's the sum of two squares, meaning if you are adding two squares? So like if I had x squared plus 25, could I turn it into an x plus 5 and an x plus 5? Well, let's check. What that means is, that means if I do FOIL, it should equal x squared plus 25. So the first would be x squared, the outer would be 5x, the inner would be 5x, and the last would be 25. Well, do you see in this case, the middle terms don't cancel. You actually add them and you're going to get 10x and then plus 25. So this does not equal x squared plus 25. So the answer to my question is a big whopping no. The shortcut does not work if it's adding two squares. So the shortcut only works if it is the difference of squares. In other words, it must be a perfect square minus a perfect square in order for it to be the shortcut. Okay, so the reason I wanted to kind of just clarify that first is because now look up here at this part. Notice it says factor each of the following using the appropriate method. So I'm not telling you if it's a common factor or if it's difference of squares. You have to choose and then factor it. Well, first thing I'm going to say is it's not difference of squares if it's not subtraction. So immediately these cannot be difference of squares. They have to be common factor. All right, so let's do common factor on those. Let's see, on number 2, I think I'll take out a 2x. And that leaves me with 4x plus 5. And on number 4, I'll take out a 4, and that's going to leave me with x plus 4. See, otherwise, number 4 might have been confusing because you might have seen the 4 and the 16 and thought it was a difference of squares. But it's a plus, and that x is not a square. It would have had to have been an x squared in order to even consider it. Okay, so now does that automatically mean that if it's subtraction, that it's going to be difference of squares? No, because then you have to check and make sure, is each term a perfect square? And in this case, the answer is yes. That'd be x plus 12, x minus 12. What about on number 3, though? Well, no, 12 is not a perfect square, so who cares about the 2? So in this case, if it's not a difference of squares, your only other option is common factor. So I could take out a 2, leave me with 6 minus x squared. Okay, I'm going down to number 5. Is it a difference of squares? I think it is. So this is going to turn into 8 plus 3x and 8 minus 3x. And then number 6, is it a difference of squares? I think so. So this could be 10x plus 11 and 10x minus 11. Okay, so that finishes out the difference of squares.